Hi, hello friends. Welcome to the today's session. Welcome to Unacademy and welcome to Srinivasarao Sir classes. My dear friends, today we are going to discuss some of the numericals on Go Back and ARQ protocol. Before entering to the numericals, let us all say our anthem. Crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. My dear friends, I would like to say that Unacademy has launched a wonderful digital content for dedicated students. It has brought all the dedicated faculty members onto a single route to provide the quality of service to a dedicated GATE aspirants and other competitive examination aspirants. My dear friends, about myself is Srinivasarao Sir, having more than 15 years of experience in the GATE with various subjects. I also had industry experience in the database side and the systems side. My dear friends, throughout my journey of GATE, I taught in many premium academies with a high success rate. Many of my students are completed their post-graduation from IITs, NITs, and Central Universities Triple ITs too. You also can have such a wonderful life just by clearing GATE examination. So to clear the GATE examination, there is some kind of guidance from the experienced faculty members. So the guidance will give you a lot of difference that how to prepare, what kind of questions you need to ask, what kind of questions you need to leave it and avoid it. So my dear friends, so in order to achieve all these things, Unacademy has provided two important courses. One is a plus course, the other one is Iconic. So in Iconic, it is nothing but you're going to get 1:1 guidance program which inbuilt having plus course. And plus course is a general course where you're going to get live lessons, quizzes, mock tests, and mock sessions and doubt clearing sessions, whatnot. Everything is available in an academy, which is 100% you can able to easily clear your GATE examination. My dear friends, so according to the subscriptions, so there are you need to pay for 12 months and 18 months and 24 months. If you apply my referral code, you're going to get a maximized discount. So my referral code is this. So use my referral code and enjoy the benefits of discounts. So after discounted, you're going to get 12 months and 18 months and 24 months. This is for plus course only. If you would like to take the Iconic batch, that's a 2-year students can able to opt for this, which consists of inbuilt plus course. So all facilities are there. Along with that, you are going to get a complete guidance from the faculty member. One faculty is going to give you complete guidance according to the time slots. So my dear friends, these are the two prices on your Iconic. My referral code is also applicable. So use my referral code and enjoy the discount benefits. So after applying my referral code, you're going to get a 12 months and 24 months subscription like this. Well, my dear friends, just you fill your form here, then Unacademy is going to give you one faculty member who can able to clear all your doubts. Okay, this is a centralized facility. So upon your request, you are going to be given a faculty member so that you can able to clear all your doubts. And Let's Crack GATE CSE is our YouTube channel. So subscribe our YouTube channel, and this is my referral code. Hit the bell icon for latest notifications and updates. Well, my dear friends, what is the first question? The first question is based on, so what are the number of sequence numbers you're going to assign? So I'm saying that window size is equal to 63 because you already know how to do this, because last session we discussed completely about go back and protocol. Now your window size is equal to 63. So here This is your sender window size and receiver window size. What is the range of the sequence number for the computer sender window size? So you see that if the window size is 63, and what is the range of the sequence numbers to compute your sender window size, which is nothing but, so if I'm considering this is your sender window size is equal to 63, obviously in go back and receiver window size is always 1. So your total window size is 63 plus 1. So what is your n bit value, or what are the range of the sequence numbers you are having? The range of the sequence numbers I'm having 0 to 63 altogether. It is a sender window size plus receiver window size, which is of 64. So what is your n bit value? Your n bit value is nothing but log base 2 of your 64, which is nothing but 2 power 6 greater than is equal to 64, and so I am following n is equal to 6 bit number. Now the second question is that I am following 5-bit sequence number. So what is the meaning of 5-bit sequence number? Your n value is nothing but 2 power 5-bit sequence number. So how many sequence numbers you are going to get? You are going to get 32 sequence numbers, which is from 0 and which is from 31. Now we said that sequence number is always starts with 0 and it goes to n minus 1, no doubt. Now we are asking, what is the frame number of your 35th frame? What is your frame number of your 35th frame? So let us deliver. As you are using go back and protocol or sliding window protocol, don't worry, both are similar only. Now the sender window size is going to be 2 power n minus 1, no doubt, which is nothing but 0 to 31 sequence numbers you are having, but sender can able to send 0 to 30 frames only. Why? Because he is able to transmit 2 power n minus 1, which is nothing but 2 power 5 minus 1. So your window size is 31. So that means 31 he will not send, he will send from 0 to 30. So in the first phase he is releasing 31 frames. The 31 frame numbers are starts with 0 and next 1 and next 2 and next 3 and so on goes to 30. Altogether they are 31 frames. But he is asking what is the frame number of your 35th transmission. 31st transmission, your frame number is a what? 30. First transmission, your frame number is a what? 0. Observe carefully. Now I want to transmit, when you get acknowledgement for the first frame, then I am going to slide your 31. Then when you get acknowledgement for 1, I am going to reuse the sequence number 0. When I get acknowledgement for number 2, I am going to send 1, n minus 1 number I am going to send. So when I am saying that 3, then I am going to send 2. That's it. You got your answer. So far I completed 31. This is the 32nd frame, 33rd frame, 34th frame, 35th frame. So our answer is your 35th frame sequence number is 2. Your 35th frame sequence number is what? 2. Please observe carefully. So up to here it is almost all 31 frames. This is a 32 frame. This is a 33, because your sequence number can be used after consumption of your 0 to n minus 1. Your sequence numbers can be reused. That is the meaning of this wrapping around. So this is 33 and this is 34 and this is 35. So 35 frame sequence number is 2. Now let us say sender window size is a 15. Please observe different varieties of questions. So sender window size is a 15. So you know what is the receiver window size. In go back and a sliding window protocol, the receiver window size is always 1 and the sender window size is what? 15. He's asking how many bits required to represent the sequence number. First tell me how many sequence numbers are there. Your available sequence numbers A, S and R. Your sender window size plus receiver window size, which is nothing but 15 plus 1, which is nothing but 16 sequence number. So in the 16 sequence number, they are from 0 to n minus 1, which is nothing but 15. Sender can send only up to 0 to 14. Upon the success of the first acknowledgement, that means first frame got acknowledged, then I am going to slide your nth sequence, n minus 1th sequence number, which is nothing but 15 only. So therefore, what is your n value? Your n value is nothing but log base 2 of your available sequence numbers. Your available sequence numbers are 16. Then I am writing that log base 2 of your 16, which is nothing but 2 power 4 greater than your 16, and your n bit value is how much? 4. Well, my dear friends, I hope so you got to understand. All the previous question is also very similar in different way. And this question is what? Directly window size is a given of sender. So I'm taking a sender window size is a 15 and receiver window size is a 1. So I need the n value, which is nothing but log base 2 of your available sequence numbers, which is nothing but 2 power 4 greater than is equal to 16. So every problem, please understand, my dear friends, carefully. Every problem, please observe. Different problems I formed and just I am posting to you. Observe that. So read the question properly. Your message consists of 9 frames. Your message size is equal to 9 frames. And they are being transmitting from A to B. That means his message size may be the longer and your frame size is a very shorter than your message size. That's why I'm constructed in the form of what? Frames. How? Your message size divided by your frame size. You are going to get how many number of frames are there in that. So total 9 frames I computed. Now you observe. But sender cannot send all the 9 frames at a time. Sender window size is only 3. So sender window size is equal to 3. That means your 9 frames are, let me write, 9 frame sequence numbers I am writing 0, 1, 2, 3, 4, 5, 6, 7, 8. So total 9 frames they are. Now sender can send at a time only 3 because your capable is only 3 only. He said that if every 5th transmission is lost, if every 5th transmission the sender sends is lost, how many total number of data transmission the sender sent to the receiver? That's the point. Now let us see. Initially, I released 3 frames as my capacity 0, 1, 2. I pushed 0, I pushed 1, I pushed 2. Now I am waiting for acknowledgement. So observe carefully. I am waiting for acknowledgement. Now he said that only every 5th transmission is lost, which means 0 success and 1 success and 2 also success. When you say that the previous frame got success, then immediately next frame is going to be sliding because we are using a pipelining concept. For 0 success, 3 is being pushed. For 1 success, 4 is being pushed. For 2 success, 5 is being pushed. Now you can remove them as they are already success. Now the current window consists of 3, 4, 5. Now you observe what is your 5th transmission. So this is a first transmission, this is a second transmission, and this is your 3rd transmission, this is your 4th transmission, this is your 5th transmission, which means this frame is going to be lost. Frame number 4 is your fifth transmission, therefore it is going to be lost. So when frame is 4 is lost, you see that 3 is a success. Observe carefully. 0, 1, 2 is a success as well as 3 is also success. For the success of 3, I am posting 6. Now you observe, as this is a last frame, then unordered frames are going to be discarded. So the sender is going to retransmit from your lost frame to your recent transmitted frame. Your recent transmission frame is a 6 and your last frame is 4. Then he is going to retransmit 4, 5, 6 once again. Now you see, next fifth transmission we want to identify, including the last and including the discarded one. So this is your first transmission, this is your second transmission, this is your third transmission, this is your fourth transmission, this is your fifth transmission. That means this is going to be the last. That means the previous frames are success. What are success? Success 4 is success. Success of 4, I am dropping a 7. Dropping is nothing but I am pushing the frame. Success of 5, I am pushing 8. Right? As this 6 is lost and these are going to be discarded. Again sender has to retransmit the last frame to recent transmitted frame, that is 6, 7, 8. Now you observe your next fifth transmission. So what is your next fifth transmission? So this is the first transmission, second, third, fourth and 5. That means this is going to be the last. And 6 is a success, there are no frames with us. And 7 is also success, there are no frames with us because everything is being dropped. As 8 is lost, I am retransmitting only 8. There is no another fifth transmission, you stop your work there. Now how many total number of transmissions I did? So total number of transmissions I did. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So your answer is total 16 transmissions done by sender to the receiver out of your 9 packets. This is one of the dangerous situation in your go back and protocol. Why? Your useful frames are only 9. So when I am taking L of U, your useful frames are 9 and the total you transmitted is 16. So 9 out of 16 is your link efficiency. Okay, my dear friends, this is a very important model, don't forget. Let us see the same question in different way. So what is that? Now I am doing 12 packets this time. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 0 to 11 are your 12 packets or 12 frames. Now I am saying that window size is equal to 4 and go back and protocol I am using. Window size is equal to 4 and go back and protocol I am using. Frame number 4 and frame number 8 are lost. Observe, frame number 4 and frame number 8 are lost. What is the number of packets that A will transmit for sending the message to B when 4th and 8th transmission is lost? It's not the packet, 4th transmission and 8th transmission is lost. So let us see what is the 4th transmission and what is the 8th transmission during data transmission. Now let us see. So I am transmitting now. First window size is a 4, so I am dropping 4 frames. 0, 1, 2, 3. So you can remove from your original message. He said that fourth transmission is lost. What is your fourth transmission? Let us write a numbering at the down. This is your first transmission. This is your second transmission. This is your third transmission. This is your fourth transmission. Got it? So frame number 3 lost. That is your fourth transmission. Okay. But 0 success. Success of 0, 4 is down. Success of 1, 5 is down. Success of 2, 6 is down. Well, now see 3, 4, 5, 6. As 3 is lost, now we are going to discard those frames. Okay. Now sender has to retransmit from your last frame to recent frame 3, 4, 5, 6. Okay. Now let us see. These are retransmitted one and these are discarded one. We will count everything because they are all come from sender only. They are being transmitted from sender only. So 8th transmission we want to highlight. What is that? This is your 5th. This is your 6th. This is your 7th. This is your 8th. Oh, wonderful. Just retransmitted one, the first packet itself is lost. Therefore, they are going to be discarded. Now again sender has to send the 3, 4, 5, 6. Okay. Now this time onwards you can go on happily because 4th transmission identified, 8th transmission is also identified. Now let us see for the success of 3. Observe carefully. For the success of 3, I am dropping 7. For the success of 4, I am dropping 8. For the success of 5, I am dropping 9. For the success of 6, I am dropping a 10. For the success of 7, I am dropping 11. Thus, all your frames are being dropped and the examiner is not asking anything about that. Next frames are going to be lost. So, they are all going to be success. So, how many total transmissions? The total transmissions are 1 and 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The answer is 20. Okay, my dear friends. So this is how we need to solve this model. Let us see the same question in different way. So 12 packets. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So total 12 packets. So window size 4. So sender window size is equal to 4. And what is the condition? Every 6th packet is lost. Every 6th packet is lost. Now observe. Let us start transmitted. First 4 frames as my capacity is 4. 0, 1, 2, 3. So they are all success because it's not a 6th transmission. So therefore for the success of 0, 4 is being done. For the success of 1, 5 is done. For the success of 2, 6 is done. For the success of 3, 7 is done. Okay. Now you observe what is your 6th packet. Your 6th packet is 1, 2, 3, 4, 5, 6. N minus 1. This is your 6th packet. This is lost. When this is lost but 4 is success, observe carefully. As 4 is success, I am going to transmit for the success of 4. I am transmitting next frame, that is 8. Now these 3 frames are also going to be discarded because they are unordered frames which are arrived to the receiver. As I am expecting a 5, but 5 is lost and 6, 7, 8 are being discarded even though they have arrived safely at the receiver. Therefore, my dear friends, what the sender has to do? he will retransmit 5, 6, 7, 8. Okay. Now tell me next sixth transmission. So 1, 2, 3, 4, 5, 6. This time the frame number 7 is going to be loose. And therefore you see that 5 success is not talking about this, and 6 is also success. That means I am going to drop 9 and 10. When frame 7 is lost and they are going to be discarded, no doubt, again sender is going to transmit 7, 9, 9, 10. Now you identify next sixth transmission after you were lost. What is your next sixth transmission? 1, 2, 3, 4, 5, 6. This is going to be lost. That means 7 is a success. I drop the 11. 8 is a success, no frames, and therefore they are going to be discarded. Again sender is going to retransmit once again 9, 10 and 11. What is your next sixth transmission after that? 1, 2, 3, 4, 5. There is no sixth transmission. You stop your work. Now tell me how many number of transmission the sender have sent to the B. So 1 and 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 is your answer. Okay, my dear friends, so this is how you need to solve. So this question is based on bandwidth is equal to 1 Mbps. Observe. And your RTT is equal to 20 ms. And your L value message size, your message size is 1000 bits. And your GB 15 I am using. What is the meaning of 15? The 15 is saying that window size of your sender is 15. Now he is asking what is the link efficiency in GBN. GB 15 is saying what is the link efficiency of GBN. So let me do link efficiency of your GBN is nothing but link efficiency is nothing but TT by TT plus 2 into TP into your N. Otherwise 1 by 1 plus 2A into N. It's also correct, no doubt. So already TP is given. You need to calculate TT. How to calculate TT? Let us go back. So I am doing TT here. TT is nothing but L upon bandwidth. Your L is 1000 bits. And your bandwidth is 1 Mbps. 1 MB is nothing but I can write in the form of 10 power 6 Mbps. So 10 power 6 bits per second I can able to write because 1 MB is nothing but 10 power 6. So B cancel ho jayega. So 10 power 3 into 10 power minus 6 S is there, which is nothing but 10 power minus 3, which is nothing but 1 ms. 10 power minus 3 is nothing but 1 ms. So you got your answer. TT is a 1 ms divided by 1 ms plus 2 into TP value already given RTT, which is a 20 ms. So directly you take 20 ms into your N value. How much is it? Your N value is 15. Add 15 there. So your answer is 15 by 21, which is somewhat 72. So I'm going to take in the form of percentage type he is asked. So into 100, which is nothing but 72% you are going to get. So very important question, my dear friends. Efficiency of the sender side you will ask. This is how you need to do it. Now you see, let me give the figures here. Your L value packet size. Your packet size is equal to 50 bytes. Propagation delay TP is equal to 40 ms. and your bandwidth is equal to 150 Mbps. He is asking what is a sender window size, SW, how much? What is the sender window size? So you can find the sender window size in a two alternative ways. One alternative way, one way I'm going to tell you, window of bits by frame size of your bits. This is your sender window. Otherwise, 1 plus 2a, either of this you follow, will get the same answer without any doubt. So let me do the first equation, WB by LB. So window of packets, how many number of packets the sender can send at a time. That's the meaning of window of packets are nothing but window of bits divided by window of, that is nothing but frame size. So your window of bits is nothing but volume of the pipe only, bandwidth into 2 into TP. Volume of the pipe. So what is your bandwidth? Already some are mentioned. Bandwidth is 150 and TP is 40 ms. So 150 Mbps, TP is 40 ms. So 2 into 40 ms. So this is 150 into 10 power 6 bits per second into 2 into 40 into ms is nothing but 10 power minus 3s. This is ms, this is Mbps. So seconds. And now you observe carefully 10 power 6, 10 power minus 3. So your answer is 150 into 10 power 3 into 2 into 40. Nothing but 80. So this is your window of bits. So you got window of bits how much? 150 into 80 into 10 power 3 divided by what is your length of your data? Your length of data is 50 bytes. Observe carefully. 50 bytes. And numerator is in the form of bits and denominator is in the form of bytes. So I'm converting into bytes formation. Therefore, this is 53 ja. This is 8 10 ja. So what is your value? 3 10 ja. 30 into 10 power 3 bits, which is nothing but 30,000. So bits cancel it. So here you are going to get only what? Metric measurement. Only 30 into 10 power 3. That is your answer. So what is 30 into 10 power 3? Your sender window size is equal to 30,000. What is the meaning of 30,000? Sender window size is equal to 30,000 frames or packets at a time. So he can send in a single stretch 30,000 frames or packets. So this one you can also do similarly using a 1 plus 2a equation. 1 plus a is nothing but TP by TT. So your TP is already given 40 ms. Your TT, you need to compute TT L upon bandwidth. Put this in this equation, you are going to get 30,000 packets. Okay, my dear friends. Let us go to next question. So I am giving you the figures down. Observe. Bandwidth is equal to 1 Mbps. And your propagation delay is already given predefined 270 ms. And your frame size is given 125 bytes. Assume no time gap between transmission of any two frames. No time gap means what? No TP for acknowledgement. That means he is keep on transmitting your frames without waiting any kind of acknowledgement. Therefore, there is no concept of what any acknowledgement propagation time. We are going to see only one direction. We are not going to expect any kind of acknowledgement. 100% they are going to be received. And he is saying that one more information, your n value is equal to 4-bit sequence number. So now he is asking, what is the channel utilization? Channel utilization is always in the form of, already we did the similar problem. What is that? Tt divided by Tt plus, here I am not going to write 2 into Tp. Why? Because I am saying 2 into Tp is only for what? Going there and coming back acknowledgement. I am saying that acknowledgements are least bothered propagation time. It is error-free channel only. Therefore, whatever you send, that is being arrived to the receiver successfully. So we are going to consider only what? Only one TP. That TP is only for transmission of your data. So only TP. And into what is sender window size? This is the hint is given to us, 4-bit sequence number. Now you see 4-bit sequence number is nothing but 2 power 4 is equal to 16 sequence numbers you got. What are your 16 sequence numbers? 0 to 10. So sender cannot send all the 16. Sender can send only up to how many? 2 power 4 minus 1, which is nothing but only 15 he can send at a time. So your window size is how much? 15 here. Now let us do the problem channel utilization. So Tt by Tt plus Tp into 15. So you need to calculate Tt value. So Tt is L upon bandwidth. What is your L? Your L is nothing but frame size 125 bytes. Bandwidth is 1 Mbps. 125 bytes divided by 1 Mbps. So denominator is in bits and numerator is in a byte. So let us convert into what? Bits. Into 8B. What is your answer? 8 into 125. 1000. So 1000 into bits cancel 10 power minus 6s, because 1 MB is nothing but 10 power 6 bits per second. So therefore what is your value? It is nothing but 10 power 3 into 10 power minus 6, which is nothing but 10 power minus 3s, which is nothing but 1 ms, or otherwise 1000 microseconds. Anything is same. 1000 microseconds or 1 ms. So what do you want to consider? We want to consider in ms only, because your TP is given in the form of ms. So let us post your channel utilization is a TT. How much it is? 1 ms. 1 ms by 1 ms plus your TP 270 ms into your 15, which is nothing but 15 by 271. This is your answer. So what is 15 by 271, which is into 100, which is a 5%. This is your answer. So compulsory question, these are all. Either model can come, but see that all these models, please do well. Now let us see the next question. A computer using the following sequence numbers, what are that? 0 to 15, one set. Again they are being reusing 0.15. After that again they are going to reuse 0 to 15. That means how many sequence numbers? Your total available sequence numbers are 0 to 15, which is nothing but 16. So 16 means what is your n value? Your n value is nothing but log base 2 of your 16, which is nothing but 4-bit sequence number. 4-bit sequence number, right? So he is asking what is the size of the sender window. The size of the sender window is nothing but total sequence numbers minus 1. Otherwise, your 2 power 4 minus 1 is nothing but 15. So our answer is, according to your go back and protocol, what is your sender window size? Or what is the size of the window? Size of the window means altogether it is 16. But what is the sender window size? What is that? It is 15. So your answer is 1.5 in this. Because the sender can able to send only up to 2 power n minus 1, not altogether 2 power n. Now let us see another question. So bandwidth is at 20 kbps. And propagation delay, TP, propagation time, data propagation time and acknowledgement propagation time, 400 ms. And I am following GBN. GB10, n is nothing but he has given 10, GB10. So frame size is 1000 bytes. So see that all questions are looking very similar but small twist. So what is the maximum data rate is possible? So far we have not discussed this question in today's session. Maximum data rate is nothing but good put or throughput or net bandwidth. These are all meaning of maximum data rate. So I'm going to find a throughput, also called as a good put, also called as a net rate. So what is your throughput value? Your throughput can be computed using link efficiency into sender's bandwidth. So link efficiency into sender bandwidth. Otherwise, you can also find throughput in this way. What is that? Your message size divided by total time. So either of the equation is correct to solve this problem, throughput. So this is two equations I am giving you. So the very famous equation is this is only. Find the link efficiency and multiply with your sender bandwidth because bandwidth is available. If bandwidth is not available, instead of finding bandwidth from TT is equal to L by B, you can directly use this equation. So you are going to get, what is your total time? You may get a doubt. What is the total time? Your total time is nothing but, as the secondary delays are negligible, I am taking TT plus 2 into TP. As he is not talking anything about acknowledgement, so acknowledgement is a mandatory in this, that is a 2 into TP. Now let us find link efficiency. What is your link efficiency? We know the same story we are repeating. Your link efficiency is equal to TT by TT plus double of your TP into window size 10. Because this time he said that window size is equal to how much? GB10. 10 frames at a time. That's the meaning of GB10. So let us calculate TT here. TT is equal to L upon bandwidth. Your L value is already given. That's 100 bytes. Bandwidth is at 20 kbps. So this I can write in this form. 800B divided by 20 into 10 power 3 bits per second. Okay. Now you see bits cancel. This is 240, which is nothing but 40 into 10 power minus 3s. I can write in the form of 40 ms. So I got TT as a 40 ms, right? So you got your value 40 ms by 40 ms plus 2 into, what is your TP? Your TP is already mentioned, 400 ms. 400 ms multiply your window size 10. So you got your answer, which is a 400 divided by 840. This is your efficiency. So your L of U is equal to 400 by 840 which is 0.47. Now what is your throughput? Your throughput is nothing but 0.47 into the bandwidth. What is your bandwidth? 20 kbps, which is roughly 0.47 into 2 and 9.52 into kbps. So roughly it is a 10 kbps, my dear friends. So what is your answer? Your answer is 10 kbps here. This is your answer. So any doubt, please post me if you are having any doubts. Now let us see the very another important question. This is a very important question which is given in the previous GATE examination. The bandwidth is mentioned as 128 kbps, right? And he said that one-way propagation delay 150 milliseconds. And protocol is GBN. Frame size is equal to 1 kilobyte. The minimum number of bits required for the sequence number field to achieve 100% utilization is asking find n bit value to get 100% of link utilization. So how to find n bit value? You can find n bit value, you already know, log base 2 of your window size or available sequence numbers, either is same. So we need to find window size or available sequence. How to find window size? To get 100% efficiency, to get 100% link efficiency, window size is supposed to be 1 plus 2a by 1 plus 2a. You're going to get ultimately how much? 100% utilization. That means your window size is supposed to be 1 plus 2a. Well, my dear friends, otherwise, there is one more equation I said. What is that? You want to calculate window size, window of bits by length of your message bits. So what is window of bits? Window of bits is nothing but bandwidth into 2 into TP by your length of data. What is your length of data? Which is 1 kilobyte. Bandwidth is this much, TP is this much. Length of data. So let us post. Your bandwidth is how much? 128 kbps into 2 into your TP is already given, that is a 150 ms. So almost all you could do, friends. Examiner will give you all kinds of hints, just you need to do fractions only. And frame size is a 1 kilobyte. So just you need to solve, you are going to get the answer. So let me solve now. So 128 into 2 into 150 ms. 128 kbps into 2 into 150 ms. ms is nothing but 10 power minus 3s divided by 1 kilobyte, which is nothing but 10 power 3. This is in bits and I need to put it in the form of bits only, multiply with 8b. Now you tell me what is the answer. You're going to get window size now. Your answer is, this is a 16. So your answer is bits cancel. So 10 power 3 and 10 power 3 is cancelled. Now what else is there, my dear friends? It is 16 into 2 into 115. Yeah, 16 into 2 into 115, 150 divided by 1000. So what is the value? 16 into 2 into 150 divided by 1000. So you got 4.8. Now for this we are going to find a what? Your window size is equal to 4.8. To this I am going to put it in the form of log base 2 of your 4.8, which is nothing but 2 power 2 is not greater than is equal to 4.8. This is wrong. So I am going to take 2 power 3 greater than is equal to your 4.8. So your n is equal to 3-bit sequence number. This is your answer. That's it, my dear friends. So this is the answer, 2 power 3. You can also do the same problem using 1 plus 2a. Please observe. A stands for, as I told you, TP by TT. You can use window size formula this. So TP is already given and TT you need to calculate. TP is a 150 ms. 1 plus 2 into 150 ms by. So TT you need to calculate, that is L upon bandwidth. Your L is 1 kb. Your bandwidth is 128 kbps. So put it there and you're going to get a value. That means 1000 into 10 power minus 3 divided by 16. So put this value and multiply. So 1000 divided by 16, which is 62.5. Now 150 divided by 62.5, which is 2.4. So which is nothing but into 2 plus 1 is a 5.8. So put this one into log base 2, 5.8. So this is your answer. But in this 5.8, you see that sender window size is equal to and receiver window size is equal to also there. We need to keep it properly. Now let us see one more question. So bandwidth is 5 Mbps and packet size is a 1 kilobyte and your propagation delay TP is equal to 200 microseconds and window size 127. Now what he is asking, what is the link of efficiency? Link efficiency is a TT by TT plus 2 into TP, no doubt. And window size is given 127, multiply with 127. So you need to understand one important thing. Instead of doing such a long process, I will give one shortcut. If your window size is greater than is equal to 1 plus 2a, then no doubt your efficiency is equal to 100%. You can simply say your answer. If window size is less than 1 plus 2a, then your efficiency is not 100%. Your efficiency is not 100%. Then what is your efficiency? Your efficiency is your window size by 1 plus 2a. Bas. That's why if your window size is a 1 plus 2a, 1 plus 2a divided by 1 plus 2a, your window size is 1 plus 2a divided by 1 plus 2a, you will get 100%. If your window size is not 1 plus 2a, if it is lesser, then you take that lesser value and 1 plus 2a. First, let us see what is 1 plus 2a value. Then I can understand that what is your window size. Your window size is 127. Is it greater to 1 plus 2a or lesser to 1 plus 2a? Let us understand. 1 plus 2a. So what is your a value here? Tp by Tt. Tp is already given 200 microseconds. Just you need to calculate Tt. So Tt is nothing but L upon bandwidth. What is your L value? 1 kb and bandwidth is 5 Mbps. 1 kilobyte divided by 5 megabyte per second. No conversion. Both are in bytes only. So directly you can start your answer. Byte cancel ho jayega. So mk and k is left. Otherwise you say that you can write like this. 1000 divided by 5 into 10 power minus 6s. MB means 6. 10 power 6. Which is nothing but 200 microseconds. You got TT also 200 microseconds only. Put it here. So 200, 200, it is nothing but 1. So therefore 1 plus 2 into 1. 1 plus 2 into 1, which is nothing but 3. Now you tell me, your window size is greater than is equal to your 1 plus 2a. Means, I said it is 100% efficiency. Your window size is a 127 is a given to you, greater than is equal to 3. Therefore, I need not do such a long process. Your efficiency is 100% here, no doubt. Because my numerator value is more than your denominator value. Otherwise, I already told you what is the equation to find the link efficiency. To find the link efficiency, it is nothing but Ws by 1 plus 2a. Right? Otherwise, if people are saying that why can't I write like this? Yes, you can also write like this. Tt by 2 into T into Tp, no doubt. But into, don't forget your window size. What is your window size? It's given 127. What is your Tt? It is what? 200 microseconds. So 200 microseconds divided by 200 microseconds plus 2 into 200 microsecond. Your Tp also 200 only. What is your value? 200 divided by 2 2s are 4 plus 2, 600 into 127. That's it. So what is your efficiency? It is more. So don't forget that multiply with 100 because we are going to see that how much percentage multiply with 100 is more than your 100%. So you can also do link efficiency like this. Otherwise, I gave you a shortcut. What is the shortcut? If your window size is greater than is equal to 1 plus 2, it is 100%. Otherwise, you want to solve, okay, solve it. Ws by 1 plus 2a, you are going to get the same. It is greater than 100%. Well, friends, so these are the different questions. We will solve the remaining questions in tomorrow's session. Tomorrow YouTube session is on selective repeat protocol. Tomorrow same time, 10 p.m. to 11 p.m. The topic is SR, the second ARQ protocol under sliding window. Already we discussed 4, stop and wait and sliding window. Both are flow control protocols. And stop and wait ARQ and GBN ARQ, they are what? Your error control protocol. So one more is left, that is selective repeat ARQ, that we will discuss. This is your YouTube timing. And tomorrow I am planning on Unacademy special class. Please all of you present and make a grand success. Unacademy special class, please download this app, Unacademy student learning app. And tomorrow I am planning from 2 to 4, 2 p.m. to 4 p.m. I am planning complete logical link control questions. That is, you are going to see questionnaire on framing, and you are going to see questionnaire on error detection codes and error correction codes, as well as flow control protocols, as well as error control protocols. These are all I planned. So that is from 2 p.m. to 4 p.m., which is on an Unacademy special class. Please visit tomorrow sharp 2 p.m. to 4 p.m. Then increase your strength, and wherever you are lagging behind, you can able to increase it. Otherwise, if you feel that you know everything, once answer all your questions. This is your tomorrow YouTube session. This is your special class session. So special class is also very important. There I am going to discuss all kinds of questionnaire on framing, EDC, error correction codes, flow control, and error control. My dear friends, please join in Unacademy using my referral code. Then I can be your guide. Otherwise, I cannot be your guide. If you join with some other promo code, I cannot able to guide you. Please join into Unacademy using my referral code so that I can be a guide to you. So we'll meet in the tomorrow Unacademy special class, that is a 2 p.m. to 4 p.m. on complete logical link control. Okay, my dear friends, thank you very much for sparing your valuable time. Tomorrow we'll meet.